Okay, 9.4 is graph and rate equations of ellipses. Ellipses, right here, if we look, an ellipse is a set of all points P such that the sum of the distance between the two fixed points called the foci. So let me draw you an ellipse down here. Here's your ellipse. And we'll fill it with white. And I will put some axes with it so you can see them. So we have an x-axis, and then we have a y-axis. And the foci are these fun little points that live kind of right here and right here. They're equal distance from the sides. They're called D's, D1, D2. And the idea is if you had a piece of string and wrapped it around the foci, these are the foci, the D's, then if you put your pencil kind of like this, kind of like if you had this piece of, like a point on here, and you wrapped it around this like a piece of string, and you followed it around with your pencil, you would get this ellipse. That's how they create it. And also, you need to know if your ellipse is horizontal, which this one is, then your major axis is x. But if you would have, let's create another ellipse here somewhere. Give me a second. And if I would have another ellipse that would look, I don't know, somewhat like this, and we'll fill it with white, and I will put my axes in it. So an x-axis, a y-axis, and again you have your foci, which would be like here. But here, your major axis is the y-axis because it's bigger on the y-axis. All right. The foci are the two fixed points, these D's. The vertices, the point at which the line goes through the foci. Okay. Major axis, the line segment that joins the vertices, center point of the major axis. Well, here, since it doesn't have anything but the origin as the center point, we have the center points here. Midpoint of the major axis, co-vertices, minor axis, we will get to all that. So here we go. Here are the formulas. These are important things to know. When your major axis is horizontal, so this is your major axis is x. I'm going to make that is x. Then a squared, x squared over a squared plus y squared over b squared equals 1. That means that your vertices are plus or minus a, right? And your co-vertices are plus or minus b. So the vertices, if this is horizontal, this will be a positive a, this will be a negative a. And your co-vertices are along the minor axis, so this would be a positive b, this would be a negative b, and that is only because that's where they're positive and negative along the coordinate plane or the x and y axis. It is opposite for the second equation, because again, this is where your vertical axis is your major axis, so that's the y-axis. So then this will be plus or minus a. Again, a is the smaller of the axes, and then this will be b, right? So here, a is y, so this will be plus or minus a. This is major, and this will be plus or minus b. Alright, so that's kind of what it looks like. And then if you look down here, it says the foci of the ellipse lie on the major axes at the distance c units from the center, where c squared equals a squared minus b squared, and that's pretty much using part of the Pythagorean theorem, making a triangle. Again, we will get into it more, but make sure you have all the drawings to go with this. Pause when necessary. Okay, here we go. Graph the equation x squared, 9x squared plus 36y squared equals 324. Identify the vertices, co-vertices, and foci. Well, right now we're just going to focus on graphing. First thing you're going to do is you have 9x squared plus 36y squared equals 324. Well, this 1. To make it 1, we're going to divide the entire problem by 324. And we're going to reduce our fraction. So that is going to give me x squared over 36 plus y squared over 9 equals 1. We are now in the form we need. And the bigger number on the bottom is always going to be the major axis. Right? So when the bigger number is under x, the major axis is the x-axis. When the bigger number would be under y, the major axis is the y-axis. So it's not that hard to graph. Okay, so we know that this is in the form of x squared over a squared plus y squared over b squared. So a squared equals 36. So a will be 6 plus or minus. And b squared equals 9. So b will be plus or minus 9. Now, I'm sorry, plus or minus 3. Now, I know that we can't have negative distances, but these are just points on our axis. Since, again, there was nothing added or subtracted to the x and y when we started the origin, we go, because a is under x, that is our major axis, we go over 6 to positive 6, and we go over to negative 6. Those are our vertices. And our co-vertices come from the positive and negative 3, which we have here. And then we just try our best to make this look like an ellipse. And right now when I'm away, we're just worried about being able to graph it. So that's how you graph that problem. So the co-vertices, here we have, co-vertices are going to be 0, 3, and 0, negative 3. And the vertices are going to be 6, 0, and negative 6, 0. Now, we can take a minute and find our foci if we would like, because they come from foci. Come from c squared equals a squared minus b squared. We know that a is 6 and b is 3, so c squared equals 6 squared minus 3 squared. And if you do the math, you get c squared equals 27. So c equals the square root of 27 along your major axis. So somewhere, I'll do this in red. So somewhere along here, we have negative the square root of 27 and 0. And maybe along here, the square root of 27 and 0. Those are our foci. So you answered all the questions. All right, next problem. Again, pause when you need. It says, write an equation of the ellipse that has the vertex at 0, 7, the co-vertex at negative 4, 0, and the center. So here, this is what's going to happen. When you have your vertex at negative 7, so let's pretend we count by 2s, 2, 4, 6, and between it's 7. And count up by 2s, 2, 4, 6, between with 7. We'll put count by 2s. Just pop in the graph to make it easier. Then your co-vertex, look, I graphed on the wrong, no, I graphed right. So your co-vertex is at negative 4, so 2, 4. And then it has to be positive 4, it has to be ellipse. It says your center is 0, 0. So graphing it becomes the easiest part. We're just going to graph like this. But what if you needed the equation, right? So if you needed the equation, we would say that A here, because major vertex goes with A, this distance is 7 equals A. Now, the minor vertex or the co-vertex goes with the shorter side, so this is B, and B would equal 4. We get that from here. This is B, it's smaller, and A is bigger. Right? And remember the equation is x squared over, and then by squared over equals 1. Well, the A has to go with the 7, so this will be 7 squared. And the B goes with the 4, so it's 4 squared. Now remember, it changes based on which is the major axis and minor axis. I like to think of it along the y-axis, 7, it goes under the y. Along the x-axis, 4, it goes under the 4. So the equation is x squared over 16 plus y squared 39 equals 1. And that is going to be the equation of this problem. All right. This says write an equation of ellipse that has the vertex at -6 and focus at 5, 0. So -6, 0 is right here, and negative, again, we'll have one on the side, and the focus is -5, 0, so we'll have another focus. So we have nothing along this y-axis. But we do know that the equation is c squared equals a squared minus b squared for our foci, right? We know this. We also know that our foci is going to be 5, because that comes from this, our focus or our foci, and that our vertex is going to be, one of our vertexes is going to be, or vertices is going to be 6. We call that A as our major one. So we're going to say 5 squared equals 6 squared minus b squared. So obviously b squared equals 6 squared minus 5 squared. So b squared equals 36 minus 25. So b squared is going to equal 11. So b equals the square root of 11, which you have to get a calculator and approximate. So let me go over here and get it. Tell you what the square root of 11 is so we can graph it. And that's approximately 3.3. So we're going to have 3.3 up and then 3.3 down. So to graph this, we just simply graph our ellipse. There it is. But if you want the equation of the ellipse, remember this is our A, this is our B. So the equation is x squared, and under x you have the 6 squared, plus y squared, and under that you have the square root of 11 squared equals 1, or x squared over 36 plus y squared over 11 equals 1. You can find it using the vertices. Here we have this equation. This one's easy. Remember, you can put a 1 under here. So we know that a squared equals 1. So a is going to be plus or minus 1. B squared equals 25. So b will equal plus or minus 5. And then b is our major axis. Goes with the y. So 2, 4, 5, 2, 4, 5. Here we're at 1 and 1. And remember, the biggest number is a. So I actually wrote this wrong. Let's go back, because the bigger number has to be your A. So these are your B's in this one, and these are your A's. So you can say C squared equals A squared minus B squared. This is so you're not getting an imaginary number when you find your foci. So C squared equals 5 squared minus 1 squared, or 25 minus 1. So C squared equals 24. So C equals the square root of 24. And that means your foci is about 4.9. It's going to be plus or minus 4. Let me write that in the right way. Your order pair will be 0 and plus or minus 4.9. Because remember, your foci lives right about here, right about there. That's your foci.